Hi, this is Mrs. Tretner, and this is the lesson on reasons for the seasons. We will be doing this check-in question during class, so if you wanted to read it over and think about it prior to class, fantastic. And then we will be discussing it in class. So if you need to read it over, go ahead and pause the video, and then we will continue. Okay, so these are the objectives that are being covered throughout the unit. The goals for today is to understand why we have seasons. In class, we will be doing some review questions. We will be talking about solar eclipses, reviewing about a solar eclipse, reviewing about a lunar eclipse, tides, okay? And I will share the video why we have night and day and seasons. It's a little bit longer video. We'll be watching part of it. The entire video can be seen when you have a little bit more time. It's about a 9-minute video, and I have the link for it in Canvas under course resources. I am going to share with you a day on Earth through Study Jams. I'll also put the link for this in Canvas.
Hey Zoe, check it out!
Almost.
No, I can do it. Watch! Oh,
Here, let me try.
sure. Show off.
Hey now, just takes a little practice. Actually, this kind of reminds me of the way the planets rotate.
The planets? Zoe, science class was like 3 periods ago.
I know, but think about it. The Earth just keeps spinning and spinning on its axis.
Guess you're right. Lucky for us, the rotation of the Earth is like night and day compared to the basketball's rotation on my finger.
That's for sure. And speaking of night and day, you know it's the Earth's rotation that causes night and day, right?
1 rotation equals 1 day, right?
Exactly. As the Earth rotates on its axis, different parts of the world face the sun, while others face away. The sun is what gives us daylight, so when a part of the Earth faces the sun, it's daytime in that part of the world. At the same time, on the other side facing away from the sun, it's nighttime. It takes 24 hours for the Earth to make 1 complete spin.
That's right. 24 hours in a day.
Uh-huh. And just like your basketball, the Earth spins around an axis. The Earth's axis is an imaginary line from the North Pole to the South Pole, and it's tilted at an angle.
Huh. I didn't know its axis was tilted.
Yeah, and the Earth orbits around the sun.
Sort of like when the basketball spins around the rim of the net.
Yeah, planets orbit the sun, and moons orbit their planets. When a planet completes a full orbit, it equals 1 year, complete with different seasons.
What causes seasons anyways?
Well, it's the Earth's tilt on its axis along with its orbit that causes the seasons. You know how we split the Earth into the northern and southern hemispheres, right?
Yeah.
Well, as the Earth makes its orbit, different hemispheres are closer or farther from the sun. The closer to the sun, the more light and warmth that part of the planet receives.
And the warmer the season?
You got it. Our summer happens when our part of the Earth is closer to the sun, and winter is when we are tilted away from the sun, meaning less light and less warmth. When it's winter here in the U.S., it's summer down in the southern hemisphere.
Any planets that have 1 warm sunny season only?
Ha ha, nice try. All the planets orbit the sun and rotate on an axis, so they've got the same deal as the Earth. However, there are a few key differences. The length of a day or a year is different for each planet.
Makes sense to me. The longer the orbit, the longer the year, right?
Yeah, and a planet's size and the speed of its rotation can make it stay longer or shorter. Like, a day on Saturn is only 10.2 hours long. It's huge, but it spins super fast. And a day on Venus is, get this, 243 days on Earth.
What? That's like 5,832 hours.
Imagine that school day.
Yeah, really. There sure is a lot more revolving around this rotation business than I thought.
Totally. Let's see if you can put your own spin on it. Think fast.
Oh, I got this, Zoe. I got this. The Earth orbits around the sun, and the moon orbits around Earth. As it orbits, the Earth is rotating too. It's the Earth's rotation that causes day and night. As the Earth rotates and makes its orbit around the Sun, it receives different amounts of light and warmth, depending on how far it is from the Sun. Ha!
Yeah, RJ. Now that's what I call a spin for the win.
So what we're going to find out here today is that in the little video clip, in the Study Jam clip, they talk about being further, closer to the sun. It's really not necessarily how close you are. Okay, so we're going to talk a little bit about that. Okay, it's probably the best way to describe what's happening, but it's not totally 100% accurate. So when we have seasons, we know that there are different solstices and there are different equinoxes. And there are 4 very distinct times of year. Okay, we just went through one of the spring equinox. We just went through the spring equinox or vernal equinox. And then there will be the summer solstice, the fall equinox, and then the winter solstice. So this is a diagram showing you how the Earth is in orbit around the sun. The tilt of the Earth does not change, okay? And that's really important to remember. The Earth is always tilted at 23.5 degrees, okay? It's when the Earth is in orbit, okay, that the tilt is different, okay? And it's just because of the position of the Earth in its orbit that causes either the northern hemisphere or the southern hemisphere to receive more light, okay? The Earth's orbit is much more, this is showing a pretty strong elliptical pattern. The pattern is a little bit more circular, and so even though the distance from the sun changes slightly, it's not a huge difference. What causes the seasons is because of the tilt of the Earth and the amount of sunlight that reaches the surface of the Earth at different times of the year is what's causing the seasons. So when the Earth is in a position in its orbit around December 21st, okay, because of the tilt of the Earth, the northern hemisphere receives the least amount of sunlight than the southern hemisphere. That's why it's cold, because the Earth, even though it's still getting, the northern hemisphere is still getting sunlight, it's not getting direct sunlight. The sunlight is spread out as it's hitting the surface of the Earth, okay? And the southern hemisphere, because it's tilted, is getting more direct sunlight, okay? As that Earth continues its orbit and the position changes, more sunlight will begin to hit the surface of the Earth in the northern hemisphere, and it'll decrease in the southern hemisphere. By June 21st, which is the summer solstice, the position of the Earth, the northern hemisphere, because of the tilt, and remember the tilt does not change, it's the position as the Earth is going around the sun, that the northern hemisphere will receive more direct sunlight than the southern hemisphere. And then as the Earth continues its orbit and the tilt stays the same, the sunlight will begin to decrease and the amount decreases of direct sunlight as the Earth continues its orbit. So I'm hoping that this illustration on the board helps with that. So in this one, you can see that the sunlight, the most direct sunlight occurs, close to the equator, okay? But and because the Earth is round, and we've talked about this, because the Earth is round, that sunlight, as it hits the northern part or the southern part of the Earth, the light will spread out. And as the light is spread out, the intensity is not as great. So when the Earth is in orbit around the sun, and because of the tilt, okay, there's less direct sunlight that will hit the northern part than the southern part in December. And then as it continues on its path and it ends up in the southern part, or in the summer solstice, more direct sunlight will hit the northern hemisphere than the southern hemisphere. And the seasons are there because of the amount of direct sunlight that the Earth is encountering in its different positions in its orbit around the sun. So what we'll be looking at in class is we'll be looking at a video, and the teacher does a really good job demonstrating with a stick that has holes in it how much sunlight the Earth is receiving at different points during the year. So we'll be looking at that video, and then we'll be answering some questions, and hopefully you'll have a better understanding of the seasons.